Hello and hi to Dr. Tan. So today I will explain about the experiment 5, which is use of airlift fermenter for the production of lipase from lipase-producing recombinant E. coli. So first is the materials and methods. So materials we use is lurea broth, microorganism, lipase-producing recombinant E. coli, phosphate buffer with pH 6.5, triton at 0.0 ml p-nitrophenyl laurate, ethanol, and distilled water. For apparatus, we use inoculating loop, 500 ml conical flask, petri dish, carton, aluminium foil, cuvette, incubator, test tube, and test tube rack. For equipment, we use airlift bioreactor, incubator, spudger, UV spectrometer, and microplate reader. So there are 5 methods in the experiment. The first method is inoculum preparation. So one loop of lipase producing recombinant E. coli was taken from the agar plate. Then it is aseptically inoculated into 500 ml conical flask. Then it was covered with a carton and aluminium foil, and lastly it was incubated at 37 degrees Celsius with 250 rpm for 24 hours. Second method is media preparation. Lurea broth was used in the experiment, and then the working volume of the bioreactor used in the experiment was 900 ml of broth media. The active culture was used as an inoculum, then the volume of 0.9 liter production medium and 100 ml inoculum medium were prepared. And then the third method is setting up the fermenter. The working volume was filled up in the vessel of the fermenter and sterile gas was introduced into the spudger, and then the medium was autoclaved for 121 degrees Celsius for 15 minutes, and the inoculum was inoculated. The temperature and pH was maintained, which the temperature is maintained at 30 degrees Celsius and pH was maintained at pH 7. Different effluent rates were used in the experiment, which is 100, 250, 500 and 1000 ml per min. The first step is dry weight of biomass analysis. So after we have handling the experiment, the samples were collected and poured into cuvette, and then by using the UV spectrophotometer, we will measure the absorbance. The the fifth method is lipase activity assay. So in this method, 25 microliter of lipase extract was made with 200 microliter of 0.05 phosphate buffer with pH 6.5, 5 microliter of triton S and 25 microliter of 0.02 m p-nitrophenyl laurate in ethanol. So then it was incubated at 37 degrees Celsius for 50 minutes. And then this sample will be measured at 405 nanometer using a microplate reader. So in the experiment, we have precaution steps we have to take to avoid any unnecessary condition. So the first is aseptic method applied during inoculum preparation to avoid contamination, such as during inoculation we must do near the flame to avoid any contamination of other things. And then the medium was autoclave at 131 degrees Celsius for 50 minutes. We have to sterilize our equipment before handling experiment. We also have to avoid vessel stress cracks, which is we have to never overtime the vessel clamping screw. We have to check the condition of the airlift fermenter. Is it okay or not? Is it okay? We can proceed with the experiment. And then the cuvette, the sample in the cuvette. So the cuvette was wiped with tissue paper to avoid any contamination. So we have the result. So this is the tabulation of data of maximum growth rate, doubling time, and volumetric productivity at different effluent rate. So we can see that we have 4 effluent rate here, which is 100, 250, 500, and 1000 milliliter per minute. So the first is maximum growth rate. The maximum growth rate was higher at 100 milliliter per minute, which is 1.4051. The doubling time, uh, the highest was at 1000 milliliter per minute, which is 0.9860, and then the volumetric productivity, we to see that the highest was at 500 milliliter per minute, which is 32,400. So we can see that the most ideal for the growth of culture is by using the flow rate of 500 milliliter per minute, because it has the highest volumetric productivity. So for the discussion, the factors which is affecting the result was the airflow rates. The higher the airflow rates, the higher the volumetric productivity. This is because a leaf reactor consists gas bubble zone between the top of the central draught tube and the baffle, which means that the high airflow rates can lead to high gas hollow-ups and enhance bulk mixing and improve dissolved oxygen and mass transfer. Thus it will promote growth. However, if you apply to high airflow rates, it will produce a zone of high shear stress, especially in the gas bubble zone, which can potentially lead to cellular damage. So, the volumetric productivity is based on the enzyme activity of each airflow rates divided with working hours. So, from the result, we can see that low airflow rates had more negative effect on lipase activity than a high flow rate. But the most highest volumetric productivity is at 500 milliliter per minute, because 1000 milliliter is considered high flow rates. So high airflow rates might has higher shear force that might have inhibit the lipase production. So in conclusion, the other airflow rates for lipase production from lipase producing combinant E. coli is 500 milliliter per minute, because it shows the highest volumetric productivity. Thank you.